Yes, today we are going to solve three problems in signal flow graphs. So coming to the first problem, for the SFG shown below, the graph determinants delta is given by, so we have to determine the determinants del here. So this is the given SFG. From this we are going to determine what is delta, that is determinant. From the Mason's gain formula, we know that determinant is given by 1 minus sum of all individual loop gains plus sum of product of gains of all possible combinations of two non-touching loops minus sum of products of gains of all possible combinations of three non-touching loops, and the formulas goes on like this. But for our SFG, for the given SFG, it is enough to stop by the third term, that is sum of the products of gains of all possible combinations of two non-touching loops. So if we come here, so if you see here, there are three loops. So the loop gain of each is given by L1 equal to minus RQ, L2 is minus UV, L3 is minus RYVX. So it is to be noted that that is first and second loop are non-touching loops, and sum of the products of gains of all all possible combinations of non-touching loops is given by minus RQ, that is you have to find the product of this and the second loop, minus UV. So because only these two loops are non-touching, and find the determinant. The determinant formula is 1 minus sum of all individual loop gains. So individual loop gains are minus RQ, minus UV, minus RYVX plus the non-touching loop gains. So we will get the answer, this one. Okay, so coming to the next question, the gain from source node x1 to output node x5 for the signal flow graph below is. So here for the given SFG we have to find the transfer function. So from the signal flow graph, the number of loops is 2, that is x3, x4, x5, x3 forms one loop, and x5, x5, that is self loop. So there are two loops here, and coming to the forward paths, there are two forward paths, x1, x2, x3, x4, x5, and x1, x2, x4, x5. So these are the two forward paths, and coming to the gain associated with the loops are given by these two equations, and gain associated with the forward paths is given by this one, M1 and M2. And coming to the non-touching loops, if you see here, there are two forward paths, and the two loops L1 and L2 are touching the forward paths. So here there are no touching loops. So the Mason's gain formula, simplified formula, is given by sum of forward path gains divided by 1 minus loop gains. So this is the formula, and just by simplifying you will get the answer. Yes. Coming to the next problem, the input-output transfer function of a plant is given by this one. So the plant is placed in a unity negative feedback configuration as shown in the figure. The SFG that does not model the plant transfer function. So you have to find which SFG does not suit this block diagram. So find that odd one out. So coming to the solution, so if you see in all SFGs, there are no non-touching loops to the forward path. But when you consider this, except the option A, option B, C, D have all the loops touching the forward path. But here in option A, there are two loops which are not touching each other. That one you should consider here. So we'll consider step by step. We'll evaluate the transfer function for each of this SFG for option A, B, C, D. Okay, so consider the option A. So the transfer function or the gain formula is given by the forward path gain divided by 1 minus, which is sum of all individual loop gains, plus the sum of the all non-touching loop gains. So which is given by this, and on simplification you will be getting this one. And also when you consider the B option, it is given by the same formula, Mason's gain formula, that is summation of the all the forward path gains divided by 1 minus the sum of all individual loop gains, and there are no non-touching loops in signal flow graph given in B option. So on simplifying this, you will get this transfer function, and also the same applies for the option C. There are no non-touching loops here, and the simplified transfer function is given by this one. And coming to the option D, so this is the Mason's formula. I have applied Mason's formula, and simplification you will be getting this one. So if you see that on simplification, option A, option B, option C transfer functions are equal to the given transfer function of the block diagram, but the option D transfer function does not match. So hence the odd one out is option D. Thank you.